Okay, guys, in the last segment, we looked at how we can draw vectors. So I can draw my change in position from one spot to another. So for example, maybe I went north certain amounts. So maybe I went, put down over here, maybe I went 35 kilometers to the north. Or maybe it was at an angle, so I could have done this. Maybe I went, let's see here, let me come up with them. So maybe I went 40 kilometers. It's at an angle, so maybe I did this. Maybe I went from the north. My angle was, let's say it's 40 degrees, 40 degrees over to the east. So we drew different vectors. So some of them were straight, right along a compass point. Some of them were at an angle. Now what I'll be talking about in this situation is, or this video, is what happens when I've got real life. Now real life, what's going to happen, I'm not just going to go one place to another. I'm not going to have one displacement. I'm going to do a lot of things. So for example, maybe I went north. I went over from my house to my friend's house. And then I ended up going to the store, picking up some snacks to work on. And then I went back over here. I decided to get some drinks at the supermarket. And I ended up over there. I decided to stay. So basically what happened is I had 3 different places I went to, 3 different displacements, we say. So I went from here to here, and I'll call this displacement 1. So it was my first change in position. I went from here to here. Then I went from this spot to this spot. So I have another displacement. I'm going to call that number 2. See how I'm using little subscripts? And then I went from here to here and ended up at this final spot. So I'm going to call this displacement 3. So I have all these changes, and that's interesting, but a lot of times I just want to know, where did I end up from where I started again? This time it's a little bit more complicated. So what happened is I started over here. This is my start position, and I ended up over here. So to figure that out, all I do is I take a line and I connect the 2 points with that line. Boom, just like that. And this line, look at this, it goes from the beginning to the end. It's like a shortcut. So if I did a shortcut, where would I end up? This is called something like the displacement resultant. My resultant displacement. What's the result of my trip? Think of it like that. So fancy word for this, resultant displacement. And that's what we really want to know most of the time. Like, where did I end up from the beginning? So we like to find out the resultant most of the time. So you have a little note. Here's a situation again where I've got a trip. I went 3 different places. And basically from the beginning, the start to the end position, my shortcut is called my resultant displacement. Okay? So basically, fancy definition for the resultant is this. It's the change in an object's position from the starting point to the end point. Starting position to the final position. And to find the dr, all you do is you add the displacements together. So in other words, i.e., draw a line connecting the starting and final positions. Okay, and final positions. And that's the dr, and that's what we're going to be doing in this video. We're going to be figuring out what the overall displacement is for a trip. So here's the deal. So same situations before. You need a compass point, you need a scale, you draw the vectors one after the other, but we use something called a head-to-tail rule or tail-to-tip rule. Here's what you do. You draw the vectors one after the other, kind of like this. See how they're following each other? You don't ever do this. Don't have 2 vectors meeting. That's wrong. You don't want to do that. So they're always following each other. And then resultant, you just connect the beginning and the end. So my resultant here would be from here to here. Remember, it's kind of like the result, the shortcut result. So let's take a look at an actual example here. So first thing we got to do is got to figure out a scale. So I got a plane flying 50 kilometers east and south for 30 kilometers. I think a good scale would be this. 1 centimeter is equal to 10 kilometers. And I'm going to have my little compass point over here. So north, south, east, west. And I'm ready to draw. So I can get on my ruler. I'm going to draw my vector. So I went first east and then went south. Let me plan it out a little bit. So I'm going to go here and draw my vector 5 kilometers to the east exactly. I use this little grid to help me out here. So 5 kilometers over here. Here you go. Over to the east. I'm going to label this vector. So this is my first vector, my first displacement. So the first section of the trip, I ended up 50 kilometers to the east. You have to label these vectors. You got more than one now. Then I went south for 30 kilometers. So I'm going to draw my vector. My next one, it's a different color here. 30 kilometers or 3 centimeters to the south. So I'm going to label this as well. This is my second part of the trip, my second displacement, D2. So this one was 30 kilometers to the south. Now to get my DR, really easy. All you do is you go from the beginning to the end. Draw a nice line. Remember, you're going from the start to the end. So I'm going like this. Look at my arrow, beginning to the end. I'm going to take my ruler. I'm going to measure this line. And I end up with 5.8 centimeters. In other words, 58 meters. Or kilometers, right? So 58 kilometers. Now here's the deal. I got to measure this angle over here. So you can either measure that angle or you can measure this angle. Makes no difference. I'm going to measure this one just because it's part of my triangle. Makes sense. So I'm measuring from the east. And I measure this angle. Let's see here. It's 30 degrees. So I measure my angle 30 degrees down towards the south. So I'm going to end up southeast. If I wanted to, I could have also done this. I could have measured this angle. This angle is 60 degrees. So another way of writing this, it should be DR, is 58 kilometers south, because I'm measuring from the south, 60 degrees over to the east. So south, 60 over to the east. Both of them are exactly the same thing. It's just two different ways of measuring. One, I measure from the east. The other, I measure from the south. But both answers would be correct. So it really doesn't matter which way you write them down. Okay? So again, the steps we did, I drew a little scale diagram. The first vector, second vector, connected it from the beginning to the end, measured the length, measured the angle. I wrote down the correct answer here. Okay? So fairly straightforward steps. One more thing we're going to do is just answer this first part of the question. What's my distance? The distance that I travel. Remember, it's how far do I actually move without a direction. So it'll be 50 kilometers plus 30 kilometers gives me 80 kilometers in total. So that's my distance. Look at my symbol. No arrow on top, just regular distance. And my displacement, change in position. See, a little arrow on top. So I have my direction over there. Okay, let's do one more example. This is a little bit more complicated here. All right, sorry about that. So in this case, I've got a little bit more complicated example I was saying. I've got this 30 meters north, and then I'm going to be doing this. 50 meters south, 30 east. What the heck is this? Well, first of all, let's do the distance. Now, distance is easy. All you do is just do this. 30 meters plus 50 meters, 80 meters. So I actually traveled 80 meters during this particular trip. I'm going to have my little compass point. First thing I do. Never enter stinky washrooms or whatever you want to do. Here's my scale, 1 centimeter. It looks like I got 10, so 10 meters. And I start drawing. So the first thing I did is it looks like I went 30 meters to the north. So here's my first vector. I'm going to measure it from here. And I over here. There we go. And I'll label it. So my first vector, I traveled 30 meters northwards. Then look what I did. I traveled 50 meters. Look, south, 30 degrees east. What the heck is that? So what's going to happen is I'm going to get my protractor. I'm going to measure from where I ended up over here. This can be my, and from the south, so down here, over towards the east. So somewhere over here. So if I've got my protractor, just get this protractor here, make it a little bit smaller. Oops. Make it smaller here. And turn it like this. And I have to make it a little bit smaller. Oops, how do I do that? Sorry guys, just going to try to figure out how to make it smaller. There we go. I'm just going to pause for a sec. All right, so sorry about that, guys. So what's going to happen is my next part here, I have to measure from the south over to the east. So I take my protractor. Oops. I'm going to bring it to where I ended up over here. It's a little bit smaller. So here we go. So there's the 0 point. Now I'm going to draw my vector from the south, 30 degrees over. So I'm going to be somewhere over here towards the east. So just draw a little line there. Move this thing over. And now I'm going to draw a line that's 5 centimeters down this way. So here we go. This will be my next vector here. So 5 centimeters. There we go. Just move this down a little bit. So here's my vector. Oops, get this out of the way. And this vector is my next one. So it's the second component of my trip. So I traveled 50 meters south, 30 degrees over to the east. There we go. Now, I want to know the overall vector. So all I do is I measure this line over here. So I'm going to go from the beginning to the end, draw my line. There's my DR. I'm going to measure the DR. Looks like it's about 2.8 centimeters, so 28 meters. Now for the angle, I can measure the angle from 2 different places. I'm going to measure it from up here. So measuring this angle, I get 28 degrees. So if I measure this angle, I'll be measuring from the east (28 degrees) down to the south. If I measured this angle, I measure 62 degrees. So I'll be measuring from the south 62 degrees over to the east. So again, there's 2 ways of writing this vector. There's no difference between them. Both of them are correct. So again, just to quickly summarize, to figure out the overall vector, you draw all the individual ones. So I did the first one, then the second one, then it connected from the start all the way down to the end, drew a little line connecting the 2. No, sorry, that's my end. I measured the length, so I got 2.8 centimeters, measured the angle, 28 or 62, and then I wrote down the appropriate answer. And that's it. So practice a couple more times. This is a really important skill if you're ever navigating. A lot of times Google Maps will do it for you, but it's important to be able to do it manually. You never know what happens. You might not have a computer around. So it's a good skill to have. All right, guys, so that's it. Take care.